In this video, we will practice factoring a variety of polynomials using techniques such as the box method, difference of squares, factoring out a GCF, and the grouping method. So listen, the box method and the grouping method can both be used on problems where we have a trinomial. So I think anytime it's an odd problem, I'm going to do the box method. When it's an even problem, I'm going to do grouping, just so I can show you a variety of methods. In either case, the first step is to see if there's a common factor. There is. All of these numbers are divisible by 3. So 3 is the GCF. If I divide everything by 3, then that's going to leave me with x to the 4th power plus 7x squared minus 30. Okay, so this is what we have. So for this problem, I'm going to go ahead and do the box method. And the key to the box method is you need a product and a sum. The product is going to be A times C. 1 times negative 30. So that's going to be negative 30. The sum is always the B value. So that's going to be 7. Now, off to the side, I'm going to make a list of all of the ways I can multiply to get 30, all right, because of the product. So, for example, that could be 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. These are all of the ways to get 30. Which one of these pairs can make a sum of 7 if I pick the signs right? How about this pair, 3 and 10? I want a positive 7. So look, if I have a negative 3 and a positive 10, that will make 7. So that means the product would have to be negative 3 times positive 10. And that indeed is negative 30. So we have found the two numbers that we need for the box method. Okay, so let's go ahead and make the box now. All right, so in the first square, we put the first term. So we will have x to the 4th power. In the last square, we put the last term. So we'll have negative 30 right here. In the other two squares, we use the two numbers that we just found. And we make them x terms. So we will have negative 3x and 10x. Next, we need to find the GCF of every row and every column. The GCF of the top row is going to be x. The GCF of the second row is going to be negative 3. Actually, I need to pause here for a second. I'm used to doing problems that have an x term right here in the middle. But this is not an x term, this is an x squared term. So whenever we write these two boxes, where I have negative 3x and 10x, we are really splitting up this middle term. So since the middle is an x squared term, for this problem, these need to be x squared instead of just x. So that's going to change my GCF. Okay, so the GCF of the top row is going to be x squared. All right, the GCF of the bottom row is still negative 3. Now the GCF of the top, the first column is x squared. Yes, and the GCF of the second column is going to be 10. All right, and that gives me my binomial times a binomial. think I'll just put it right here. So from the side over here, I will have x squared minus 3. And across the top, I have x squared plus 10. But do not forget the GCF that we had right from the beginning of the problem, because that should be here in the front of everything. And this, my friends, is the final answer. So for problem number 2, this time I'll try doing the grouping method. First we look and see, is there a common factor? There is not. So we move on to the product and the sum. So we need a product and a sum. The product is always A times C. 1 times negative 48. So that's going to be negative 48. The sum has to be the B value. So that's going to be positive 2. Now, let's make our list based on the product. So I'm just going to look at this 48. And I want a list of all of the ways I can get 48. Okay, so for example, 1 times 48, 2 times 24, 3 times something, 16. Yeah, that's right, 3 times 16. 4 times 12. And 6 times 8. These are all the ways to get 48. Okay, I was stumbling around just a little bit there. Maybe some of you might have stumbled as well. So let me show you a little trick that you can use to get this list very easily if some of the numbers don't just pop into your head. So here's a little trick that you can use to generate this list using your calculator. If you hit the table button, let me just clear this out. Take the number that you want to make a list for, and you type that in first. And then just put divided by x. Hit enter. All right, start at 1. And just hit enter. For some reason, this is on ask. I don't want it on ask. I want it on auto. Okay. And really, it's giving us the list right here. So you see the 1 times 48, the 2 times 24, the 3 times 16. It's all here. And I can just scroll down. Okay, you see that 4 times 12. You see 5 has a decimal, so that's why that doesn't make the list. But then you see we have 6 times 8. Okay? And then if we keep going, it starts to repeat, because 8 times 6 is the same as 6 times 8. So that's how you can just get the list off your calculator if you ever need it. Anyway, back to this. Which one of these pairs can give me a sum of 2? Oh yeah, 6 and 8. If I pick the signs right, I can get a positive 2 out of this. So let me think. I want a positive 2. So I need a negative 6 and a positive 8 in order to do it. Okay, and then of course the product has to be the same number. So negative 6 times 8 is negative 48, so this is great. So this time we're doing the grouping method. So here's how the grouping method works. I'm just going to copy down this trinomial with one little twist. I'm going to split up the middle term into 2 separate terms. All right, but the first term, I'm just going to bring that down unchanged. So I have u to the 4th power. The last term, negative 48, I'm just going to bring that straight down. Okay, but the middle term, I'm going to split that up into 2 terms using the numbers that we just found. Okay, and because these terms are coming from u squared, these will be u squared. So I will have negative 6 u squared and plus 8 u squared. All right, I'm just splitting up the middle term. So now I need to find the GCF of the first pair and the GCF of the second pair. So the GCF of the first pair is going to be u squared. Okay, and the GCF of the second pair is going to be 8. Now, once I have the GCF, I divide by it. So I will divide these two by u squared, and I will divide these two by 8. So that means inside the parentheses, I will have u squared minus 6. And over here, I will have u squared minus 6. Notice that the parentheses are exactly the same. That should always happen when you're doing the grouping method. Because these are the same, that means the parentheses are a common factor. And whenever we have a common factor, we simply put it out to the front. So I will take my u squared minus 6 and put it in the front. That is going to leave behind the u squared and the 8. All right, if I take the parentheses away, I will still have u squared plus 8 left. And that's why this is my final answer. Okay, so for problem number 3, we're going to go back to the box method. The first step on any problem is to look for the common factor, if there is one. All of these are divisible by 6. So that's going to be the GCF of this problem. So if I take a 6 out, and then if I divide everything by 6, all right, because you always want to divide by your GCF, then that's going to leave behind u to the 4th power plus 6u plus 9. All right, so for the rest of this problem, I'm going to focus on the red trinomial. I'm going to factor that. However, for your final answer, don't forget to put 6 in front of it. Okay, so we're going to do the box method, which starts off with a product and a sum. The product has to be A times C. So 1 times 9, so that's 9. The sum is always the B value, so that's going to be 6. So now we need to make our little list based on the product. So since the product is 9, let's think about all of the ways of getting 9. So it's going to be either 1 times 9 or 3 times 3. All right, that's the end of the list. Now, which of these pairs can make a sum of 6? Well, obviously, 3 and 3. I don't even have to change the signs. 3 plus 3 is 6. And 3 times 3 is 9. So we found the product and the sum using the same numbers. We're good. So that means we're ready to make the box now. Okay, so the box is going to be like this. In the first square, we put the first term, so u to the 4th power. In the last square, we put the last term, so that's going to be 9. Now, be very careful for the other two. I need you to understand that the other two squares are based on the middle. And this is forcing me to remember I made a little mistake right here. This was u squared, so this should be u squared. And so when I do these two boxes, they should also be u squared. So I'm going to use the two numbers that we just decided on, but these will be u squared because of the middle is u squared. So 3u squared and 3u squared again. Now we can go ahead and do the GCF. The GCF of the top row is u squared. The GCF of the bottom row is 3. The GCF of the first column is u squared. And the GCF of the second column is 3. All right, that's going to give me a binomial times a binomial. So the binomial is going to be u squared plus 3 and another u squared plus 3. But please don't forget the number in the front. The original GCF is part of the answer, so this will be the final answer to number 3. For number 4, we will neither use the box method nor grouping because this is not a trinomial. When you see a binomial like this, you should still look and see if there is a GCF. There is no common factor, so most likely this is going to be the difference of squares. And sure enough, that's what this is. Difference means it is subtraction, and then both of these are perfect squares. So what happens is, when you have the difference of squares, it's always going to factor as a sum and a difference. And then we're just going to factor these out evenly. We're going to split them apart evenly. So x to the 4th power would be x squared times x squared. And then 81 is 9 times 9. So this is the difference of two squares. Now, a common mistake would be to stop right here. However, if you look closely, you'll notice that we have the difference of squares again. One of these two can be factored further. Which one is it? Well, it's this one. This is the difference of squares again. It has to be subtraction. This one on the left can't be factored anymore because it is addition. But this one can be factored as x plus 3 times x minus 3. And then you just bring down the first one as it is, x squared plus 9. So this would be factored completely. For number 5, we're back to trinomials. So I think on this side we're going to do the box method. So I'm going to do this one by the box method. So first I look for a GCF. There is no common factor. So I go ahead and do a product and a sum. The product is A times C. So the product is 4. The sum is the B value, which is going to be negative 5. Now, I start with the product, which is 4, and I start making a list. All of the ways I can multiply and get 4. Well, it's going to be a short list. It's either 1 times 4 or 2 times 2. Now, which one of these pairs can give me a sum of negative 5 if I pick the signs right? Well, that's going to be 1 and 4. I can make negative 5 if I make them both negative. Negative 1 and negative 4 make negative 5. And then the product has to involve the same two numbers. So negative 1 and negative 4. Now that we have the numbers, it is time to make the box. In the first box, we put the first term, which will be x to the 4th power. In the last box, we put the last term, which is 4. In the other two boxes, we put the two numbers that we just found, which will be negative 1 and negative 4. Now, I used to say we just make these x terms, but that's really because the middle is usually an x term. But now I have to be more careful, because on this problem, the middle is x squared. So these should both be x squared. All right, these two have to match the middle. Now we will do the GCF. The greatest common factor of the top row is x squared. The greatest common factor of the bottom row, whoa, there is no common factor, so that means the common factor is 1. And since the first term is negative, we better call it a negative 1. Okay, now the GCF of the first column is x squared, and the GCF of the second column is negative 4. Obviously, they're both divisible by 4. I'm going with negative 4 because the first term is negative. So that will give me the final answer. Looking at the left side, I have x squared minus 1. Looking at the across the top, I have x squared minus 4. Ha! Did I say this was the final answer? I was mistaken. Because now I'm seeing that both of these are the difference of squares. Both of these can be factored further. I feel like I should use 2 different colors now. So the first one, x squared minus 1, that's going to factor as x plus 1 times x minus 1. And then the second one, alright, this is also the difference of 2 squares. This can be factored as x plus 2 times x minus 2. Okay, so that will give us the final answer. Alright, that's what I call a final answer. Alright, let's do one more problem on this video. This time we're going to try the grouping method. So first we look and see, is there a common factor? Yes, all of these are divisible by 2. So 2 is the GCF, so I'm going to go ahead and pull that out front. Alright, so that means, of course, I'm going to divide everything by 2. Alright, you always divide by your GCF. So inside of the parentheses, I will have a to the 4th power plus 4a squared minus 32. Okay. So it's time for the product and the sum. So I'm going to need a product and a sum. The product comes from doing a times c. So 1 times negative 32, of course, is going to be negative 32. The sum comes from the b value, so that's going to be 4. Now it's time to make the list based on the product. So we need a product of negative 32, so I'm just going to use the 32. So what are all the ways to make 32? So that's going to be 1 times 32, and this is even, so it's definitely divisible by 2. That's going to be 2 times 16. 3 does not go evenly into 32. How about 4? Well, 4 times 8 is 32. And what else? That's it. So, which of these pairs can make a sum of 4 if I pick the signs right? Well, it's this pair right here, the 4 and the 8. Okay, so 4 and 8. If I want a positive 4, I'm going to need a negative 4 plus 8. That would make 4. And of course I need to use the exact same values for the product. Negative 4 times 8 is negative 32, so we are golden. Now, we are doing the grouping method. So what you do is you start copying down this trinomial that's here in red. So first I write down the first term, which is just a to the 4th power. And then I'm going to write down the last term, which is negative 32. All right, I just bring these two terms straight down. But the middle, something different happens in the middle. I'm actually taking the middle term and I'm splitting it up using these two numbers that we just found. So I'm going to have negative 4a squared, because I'm splitting up an a squared term, and plus 8a squared. So you can see I have not really changed anything. I should be looking at this red trinomial. I haven't really changed anything, because if I combined these two terms, they would make positive 4a squared. So in this form, you can see that we need to do the GCF of the first pair and the GCF of the second pair. The GCF of the first pair is a squared. And then I'll have some stuff in parentheses. The GCF of the second pair is 8. And then I'll have my parentheses. So what's going to be on the inside? Well, if a squared is the GCF, that means I need to divide everything by a squared. And if 8 is the GCF, that means I need to divide everything by 8. Now if I do that, I'm going to be left with a squared minus 4. And on this side, I'm going to be left with a squared minus 4. Notice that the parentheses are the same. That should always happen when you're doing the grouping method. You should get the same thing in the parentheses. If you don't, you made a mistake. You need to go back and double check your work. Now, because these are the same, that makes a squared minus 4 a common factor. And when you have a common factor, you should always pull it out to the front. So I'm going to put my a squared minus 4 in the front, and then I will write down whatever's left behind. Well, if I take away the a squared minus 4's, that's going to leave a squared plus 8. So I will have a squared plus 8 in the other parentheses. Now, sometimes the problem is over right now, but not this particular problem, because a squared minus 4 happens to be the difference of two squares. So you really have to watch out for that. So that means this can be factored more as a plus 2 times a minus 2. Now, a squared plus 8 cannot be factored because it is a sum. It has to be the difference of two squares. Also 8 is not a perfect square. So anyway, I'm just going to bring this down unchanged, a squared plus 8. Now, this is almost the final answer, except for we need to make sure we don't forget the GCF that we pulled out at the very beginning of the problem. Alright, that GCF is still going to be part of the solution. So this will be the final answer for number 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.